Thank you for being on time. This presentation is open for questions. Ask him, not me.
Ben, what is known about the direct effect of high pressure on the binding of your marker, the fura? Because as far as I know, there is not much information about that.
There is not much information, thus I cannot tell you.
You have something?
No, I have not.
Do we know how long the elevation of basal calcium was persisted after it was exposed to pressure?
At least 20 minutes.
But
did you follow it longer?
yes, I guess it was.
I'll go back to the slide. Okay, so you can see here an elevation of the basal levels, a further elevation, and then it remains for, I mean, the total time is more than 2 hours.
Are there any data past 2 hours? I'm just curious. Did you, happen to go get a cup of coffee and come back and see it was still elevated?
We never went for a coffee.
That's right. You and Raffaele had other...
we didn't have time to go for coffee.
No, we didn't need to go anywhere. It was just there.
That's right. Yeah. No food in the lab, though, remember?
It was outside the door. But anyhow, this slide, this figure is only for one experiment. We have at least 20 of them. But this is quite typical. The levels has remained high, and for now I analyzed most of them. I have not seen any reduction as decompression has occurred.
Yeah, this is interesting because I'll show later that we've seen some plasticity of just pressure alone at these same levels of pressure. That obviously this was quite a bit longer time course than what you're looking at, but it'd be interesting to know if this is maybe...
It could be, but we were always eager to go to decompress after a couple of hours to see if some activity is recovering. And we didn't have time for coffee. And if we had some time, Ben was working and I was biking to the next McDonald's or to bring some sandwiches to go on during the night. As you look at this guy, he eats a lot. So I need to feed him. Needed to feed him. Yes, any more questions?
And very nice work. Question, these prolonged elevation in calcium, do you know whether that's really an increase in the basal level, basal activity in the calcium channel, or is it a failure of this calcium sequestration?
You mean the reuptake?
Yeah.
I haven't shown it here, but we used a reuptake blocker called, Rami, help me out? I can't remember the blocker, but our first experiments were using
Tapsigargan, yes.
Yeah,
Sorry, thank you.
Our first experiments were using this blocker in order to verify that the elevation or the actual measurement we do is of calcium entering through the voltage-dependent calcium channels. And we saw that tapsigargan had no significant effect on the calcium levels. So that leaves out the calcium reuptake from our measurements.
So in which case, how do you explain that you don't get any calcium augmented, calcium activated uptake? Because if you elevate internal calcium, you'll get an increase in the basal activity of calcium channels.
It's true.
I'm sorry. Can you repeat that, please?
There's a positive feedback between the intake of calcium and the activation of voltage-regulated calcium channels, such that if you do not sequester the internal calcium, then you increase the actual influx of calcium into the cell. This is what leads to calcium excitotoxicity.
Okay.
So what you're showing is really quite unusual in that you've got what appears to be an increase in the basal level, which is not inducing any calcium-induced calcium uptake.
Could be.
What I'm suggesting is, as shown in this work, that pressure might lead to cell membrane slight depolarization that would open more calcium channels in the population of the voltage-dependent calcium channels, allowing more calcium to flow in on the basal level, even before the stimulus.
What I see your point, and on the long run, we may also affecting the uptake of calcium into the intracellular stores, whatever they are. It's a possibility. What we have with the TAPSI guarding, we mainly studied the transient effect when we stimulate, and this was not affected by TAPSI guarding. I'm not sure we have the data right now fully analyzed for the steady state level with TAPSI guarding. So we have to go and reanalyze it and see for the long run. But we didn't study TAPSI guarding. No, we did some under pressure, but not all. So it's still maybe a question whether we affect with the pressure the uptake mechanisms as well, at least on the steady state level. Yes, it's a possibility, I think.